In lesson 3.1, we will be looking at power functions. So first we're going to go ahead and define a power function. It is in this case, for our purposes, a polynomial function. It's not always a polynomial function. In the form f of x equals c times x to the n, where c and n are both real numbers. For our purposes in this lesson, our value of n will just be positive integers or the whole numbers. So that's why it has polynomial here in parentheses, because our purposes we are going to be looking at polynomial functions. So first we're just going to look at this first power function. I guess another way we can mention this is going to be x to a power. Could have a coefficient other than 1, but you just have one term and it's x to a power. So here we have f of x equals negative 2x to the fourth. Evaluate f of negative 1, f of 0, f of a half, and f of 3. So we're going to find those 4 specific points, and then we're going to find the degree, the domain, the range, and the graph of the function. So here we go. To find f of 1, negative 1, we just put negative 1 into the function. So we're using this function here, f of x, put negative 1 in for x to the fourth power is 1. So negative 2 times 1 is negative 2. So f of negative 1 equals negative 2. Then we're going to plug 0 in. Well, plugging 0 in, you get 0 to the fourth is 0 times negative 2 is 0. So we have the point 0, 0. Plugging in a half. So we have negative 2, putting 1 half in, 1 half to the fourth is 1/16. Negative 2 times 1/16 is negative 1/8. And then lastly, f of 3, we're going to put 3 in for x. 3 to the fourth is 81. 81 times negative 2 is negative 162. Those are the values. The degree is easy to see. It's just one term. It's x to the fourth, so the degree is 4. We're going to go ahead and graph these points. So we're counting by fourths here. So 1, 2, 3, 4, that's negative 1. So when we put negative 1 in, we got negative 2. When we put in 0 in, we got 0. Graph is a little bit off. When we put 1 half in, we get negative 1/8. And when we put in 3, it's negative 162, which would be off of our graph. So there's the graph of our function. And again, notice our points are a little bit off. Apologize for that. Our domain is the real numbers, and the range, this should be all the way up at 0, 0. So the range is y is less than or equal to 0. And we already mentioned the degree is 4. Here's another one. Graph g of x is 1/2 x cubed. Give the domain and range. All right, well, to graph it, here's our graph. This is a polynomial function, so we still know about our tails or the end behavior. The left is going to be down, and the right is going to be up. We can choose a few points. The symmetry is just an odd, so symmetry, it's symmetric to the origin. It has point symmetry. We'll find g of 0 is 0. Plug in 2. 2 cubed is 8. Half of 8 is 4. And so since there is symmetry, there's a point here at 2, 4. So there's going to be a point at negative 2, negative 4. And then we can go ahead and graph that. The domain and range are both the real numbers. So all functions of the form f of x equals c x to the n, where n is a whole number, The domain is the reals. I should say reals down there. All right, even and odd functions. Mentioned this before with our polynomial functions, but we talked about even functions is going to be a general idea for many different functions. And if a function is even, it is even if and only if f of x equals f of negative x for all values of x in the domain of f. So basically this is saying, let's pick numbers. If I put 3 in for f, I should get the same y value as if I put in negative 3. And we know that like a y equals x squared is an even function. Here's another way to say each x value and its opposite are mapped to the same y value. It's symmetric about the y-axis, which we talked about last chapter. So here are a couple examples of some even functions. Notice when x was 2, y was 4, and we want to look at the opposite of 2, which is negative 2, the y value was still 4. So that's how that works. Odd functions. A function is odd if and only if when you plug in negative x, you always get the opposite y value for all x's in the domain of the function. The way that we can say this in words, if x is mapped to a y value, then the opposite of x is mapped to the opposite y value. And it's symmetric about the origin, which means it has rotational symmetry about the origin. Here are a couple examples, y equals x cubed, and y equals negative 0.1 x to the 5th. So those are odd functions. When we're talking about just power functions, if they have even degree, they're even functions, and ones with odd degree are odd functions. Last thing we're going to do, we are going to determine if these functions are even, odd, or neither. Now, we can look at them from last section, or last chapter. We can easily know, but I'm going to go ahead and use a test here, and this test can be used for all types of functions, not just these few functions here, or not just polynomial functions. So the test is we're going to plug in negative x into the function, and we're going to see how that compares to the original. So we plug in negative x and see how it compares to the original. So determine whether f of negative x is equal to the original, the opposite of the original, or neither. So let's try the first one. We're going to put in negative x. Well, if we take negative x and cube it, negative x times negative x times negative x, that's just going to be negative x cubed. So is that equal to the original, the opposite of the original, or neither? Well, it's the exact opposite because we have a negative sign and this was positive here. So it's the opposite, so that means it is going to be an odd function. 3 dots there means therefore f is an odd function. The next one, we're going to put in negative x. Well, negative x to the 4th is a negative times a negative times a negative times a negative is going to be a positive. Same idea here, a negative times a negative is a positive. So to simplify that, that would actually just be x to the 4th plus x squared, which equals the original. If when you plug in negative x, it equals the original, it is an even function. Last one, plugging in negative x, we get negative x cubed plus 2 times negative x. Well, this first term will be the opposite, so negative x cubed. The second term will be negative 2x, and the last term will be positive 5. Well, it's neither, because this is positive, this is negative. This is positive, this is negative, but both of these are the same. So it's neither odd nor even.